So guys, in this video we will discuss about the solution of differential equation by Euler's method. So now let's check that how can we solve the uh, differential equation by using Euler's method. So here if we consider that a differential equation dy dx is equal to f of xy with the condition with the initial condition y of x0 is equal to y0, then how can we solve this differential equation dy dx is equal to f of xy? So now let's check how can we solve it. So here if we consider the differential equation dy dx is equal to f of xy, give it number 1, and y of x0 is equal to y0, give it number 2. So now if we take let y is equal to phi of x be the solution of number 1, and also that if we take that x0 comma y0, x1 comma y1, and also xn comma yn be the points on the curve y is equal to phi of x, and where x0, x1, x2, xn all are equidistant with the difference with the length h. That means here we can write that x1 minus x0 is equal to x2 minus x1 is equal to x3 minus x2 dot is equal to xn minus xn minus 1 is equal to xn plus 1 minus xn is equal to h. So here we can write from here also that x1 is equal to x0 plus h, x2 is equal to x1 plus h, and xn plus 1 is equal to xn plus h. So now these are, and we have to keep it in our mind while we solve the differential equation by using the Euler's method. And now we can say that yn plus 1 is equal to phi of xn plus 1, and from here we can write also this is phi of xn plus h. And now here if we use the expansion, that is we can write here that phi of xn plus h phi dash xn plus h square by factorial to phi double dash xn plus and so on. And see here that if we consider, and here we have to keep in our mind that this h is very small. So now for that, since h is very small, so we can neglect the higher power of h. So from here we can write that phi of xn plus h phi dash xn, and here we can write the neglecting the higher power of h where the h is very small. So now from here we can write that yn plus 1 is equal is price, that is phi of xn plus h phi dash xn. And see here that phi of xn means yn, so we can write it yn plus h, and phi dash xn means h y dash xn, and y dash xn means from here that is y dash xn means we can write f of xn comma y. So from here we can write yn plus h f of xn comma y. And now if we find here that if we put here n is equal to 0, 1, 2 in this equation, now if we put n is equal to 0, 1 and so on, so what we get, that is y1 is equal to y0 plus h f of x0 comma y0, y2 is equal to y1 plus h f of x1 comma y1 and so on. So this is the working formula to find or to solve the differential equation by using Euler's method. So now here I am going to solve one problem by using Euler's method, and this will give you a clear idea that how can we solve a numerical differential equation by using Euler's method. So right here the question, let's solve by using Euler's method, the following differential equation. In short I write DE for x is equal to 1, taking h is equal to 0.2, and also dy and the equation is dy dx is equal to xy with y of 0 is equal to 1. So now let's start that how can we solve it. So now here I am just going to solve this equation. See here that this is the question, that is dy dx is equal to xy. It is given h is equal to 0.2 and y of 0 is equal to 1. So from here we can say that x0 is equal to 0 and y0 is equal to 1. So now from here I have to just construct a table for solving the differential equation. So here this is n, this is an, sorry, this is xn, yn, next one is f of xn comma yn is equal to xn yn, and this one is yn plus 1 is equal to yn plus h f of xn comma y. So here first n is equal to 0 and x0 is 0, y0 is 1. So here x0 into y0, this is equal to 0 into 1, 0. And this one we will get y1 is equal to y0, that is 1 plus 0.2 into 0 into 1. So we will get y1 is equal to 1. So here now we put n is equal to 1, and here we have to remind the result xi plus 1 is equal to xi plus h, or here you can put the result that x1 is equal to x0 plus h, x2 is equal to x1 plus h, x3 is equal to x2 plus h, and so on. So here when we find x1, that is x1 is equal to x0 plus h, so the value will be 0.2, and already we find the y1, the value of y1 is 2. This will be x1 into y1, that is 0.2 into 1, so it will be 0.2. And y2, the value of y2, that is y1 plus 0.2 into x1 y1. So what we get from here, that is the value of y1 is 1 plus 0.2 into 0.2 into 1, that is 1.04. Okay, so we get the value of y2 is equal to 1.04. So now if we put that 2, that is here we have to use this result x2 is equal to x1 plus h. That is 0 0.2 plus 0 0.2, that is 0 0.4, and y2, the value of y2 is 1.04. So this is x2 y2, that is 1.04, that is 0 0.4 into 1.04, this is 0 0.416. And so similarly we have to find the y3 value, that is y2 plus 0 0.2 into x2 into y2. So what we get from here, that is the value of, that is from here we will get 1.04 plus 0 0.2 into 0 0.416. So we get the value from here, that is if we calculate we will get the value 1.1232. So next what will be the value, that is for n is equal to 3, that is x3 is equal to x2 plus h, that is 0 0.4 plus 0 0.2, this is 0 0.6. The value of y3 already we get 1.1232. So this will be x3 y3, and this will be the value, that is the value will be 0 0.6 into 1.1232. So from here what we get, that is 0 0.67392, and the corresponding y4 it will be 1.1232 plus, that is if we follow the formula, that is y4 is equal to y3 plus h f of x3 comma y3. So we get 1 plus 0 plus 0 0.2 into 0 0.67392. So from here we get 1.257984. Similarly, now if we put here, now I think you will get the scenario. This is 0 0.2, this is 0 0.8, corresponding y2 is 1.257984, and x4 y4 will be, that is the multiplication of 0 0.8 into 1.257984, and you will get 1.00639, and the corresponding y5 will be y4 plus h f of x4 y4, and if you calculate it you will get the value 1.45926. And now for the 5, that is 0 0.8 plus 0 0.2, that is 1.0, and the corresponding y5 will be 1.45926. So this is the ultimate result, that is for x is equal to 1, the value of y is 1.45926. This is the required answer. So I hope you understand that how can we find, or how can we solve the differential equation by using Euler's method. So thank you for the watching.